Okay, you may have found that that last video was actually, it was a little difficult with the double iterations. So let's actually go into multiple iterations and let's see what happens for that. So this is going to get actually, it's seemingly longer, but we're going to set up in a way that's easier to do it. Okay, so let me clear that out and let's get going here. Okay, so we had just looked at a couple of cases where we were able to simply do the process twice. So I'm not talking about the last one where we had to add back on, but we had looked at the problem x squared times cosine x integrated with respect to x. And we had to come up with an answer for that. Let me, though, set this up in a different way. Remember that when we did this, I'm going to set this up as a table. We chose u to be 2x. I'm sorry, x squared, and we chose dv to be cosine of x. And if we stick to our columns, we can see we keep taking the derivative of u. Okay, so in step 1, we took the derivative and we ended up with 2x. In step 2, we took a derivative and ended up with 2. If we took one more derivative, we would end up with a 0, which ends the game. dv, on the other hand, was cosine of x, and we need to integrate that. All right, so we're going to integrate the second column. And so when we integrate cosine, we get sine. When we integrate the sine, we get negative cosine. And if we integrate that one more time, we have a negative sine of x. Now, what do we do with this? Okay, this is the nice part of this. This is speed integration by parts. Whoops, I meant to do that in red. All right, we have diagonals. And if I write out the diagonals with alternating signs, so this one is plus, minus, plus. So if I write these out in order, I get x squared times sine of x. And then the next one would be minus, but you'll notice it's negative cosine, so it's plus 2x cosine of x. The next one is a plus, but there's a negative sign, so it's minus 2 sine of x. And then if we tack a plus c on the end, that's exactly the answer that we had gotten. All right? Now, why might that be really nice? Let's keep going. What if I had this problem instead? What if I had the integral of, let's just go with x to the 4th times sine x dx. I can set this up in the two columns. So I can have my column that I'm going to differentiate, that's my u, and I have my column that I'm going to integrate. In fact, I'll put an integral of dv here. So we're going to integrate that column. Actually, I'll get rid of that because that's inconsistent. I have to either write that I'm taking derivatives or not. So let me stick with what I had before. I write these at the top. And these derivatives are easy. 4x cubed, 12x squared, 24x, 24. Wow, there will be a lot of terms. And then finally 0, that's the end. Let's keep integrating sine. So it's negative cosine of x. The integral of that is negative sine of x. The integral of that gets me a positive cosine. Whoops, that was a smudge on the paper. Make sure that you don't get that as a negative sign in there. So positive cosine of x, and then sine of x is the antiderivative of cosine, and then we're back to a negative cosine of x. Wow, so that was pretty quick to do. Now all I have to do is connect the diagonals. Sure I get them right. There we go. And it's plus, minus, plus, minus, plus. So the answer is going to be negative, the first diagonal, it's a positive, but there's a negative cosine. So negative x to the 4th cosine of x. Then it's a double negative, so plus 4x cubed sine of x. And then the next one is a plus sign, and they're all positive, so plus 12 x squared cosine of x plus dot, dot, dot. Bring that down here. So then we have, actually I shouldn't do that. That has two plus signs, so I'll just put the plus down below and keep going. So I was down to the 12x squared. Now that gets me to 24x. Oh, that's a negative one. So that's 24x sine times sine of x. And that should have been a negative. That's one of the negative terms. All right. And then we're back to a plus sign again, but it's a negative cosine, so minus 24 cosine of x plus c. It's easy to forget that at the end. That is the answer. If we had done that through an iterative process, not only would we have had 2 iterations, it looks like we would have had 1, 2, 3, 4 iterations because we're working with x to the 4th. That would have been a lot of work to do the other way, and we probably wouldn't have ended up with the right answer. Okay, so I should say a correct answer. Let's just do 2 more to make sure that we understand this process. Let's do one that we did already, x squared e to the x. You can convince yourself that this process works because this is one that we did. So x squared is going to go there. E to the x will go over here. This is very easy because we have 2x, 2, and 0 when we take derivatives. And integrating e to the x is as easy as differentiating it. Now, put in your diagonals. Plus, minus, plus, right? So the answer must be x squared e to the x minus 2x e to the x plus 2 e to the x, right? We can kind of show why this works. If I were to take the derivative with the product rule, I'm going to get, I'll start with x squared e to the x plus 2x e to the x. I sort of did it in reverse order on purpose. And then if I take the derivative of this one, including the negative sign in there, I'm going to have, for the first term, I'll have negative 2x e to the x, and then I'll have minus 2 e to the x. And if you look at the chain of things here, there's always this kind of chain reaction where those cancel, and then those two cancel when you do this process. And so what are we left with? We're left with the original integrand. And this will work every time. So we can do more interesting, higher power ones. Let's do the integral of x to the 5th e to the x dx. You would not want to do this through iterations, but with our little chart, you have u, you have dv, x to the 5th, e to the x, 5x to the 4th. Oh, I better make this a long chart. 20x cubed, 60x squared, 120x, 120, and finally we get to the end. The nice thing is this column is all e to the x, 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 and e to the x. Put in the diagonals. Plus, minus, plus, minus, plus, minus, and the answer is x to the 5th e to the x minus 5x to the 4th e to the x plus 20x cubed e to the x. Let's see, minus 60x squared e to the x plus 120x e to the x. Okay, and finally minus 120 e to the x plus c. Actually, would be a nice way to express this answer since they all have e to the x, so let's keep it in there, would be to say this is e to the x times x to the 5th minus 5x to the 4th plus 20x cubed minus 60x squared plus 120x minus 120 plus c. So that would be a good way to express the answer. Okay, so you can see how we can do higher powers quickly. There's a pattern that emerges. So while the iterative process seems tedious at first, it actually leads to a nice pattern for many problems, especially the ones that have just x to a power. You can take those derivatives very quickly, even if it's a higher power of x.